In this video, let's see one of the application of differential equation, which is nothing but orthogonal trajectories. So what do you mean by orthogonal trajectories? What is so familiar with the word orthogonal? We know that two curves, they intersect each other orthogonally if the tangents at the point of intersection are at right angles. So geometrically or theoretically, we can say that family of circles, say x square plus y square is equal to a square, and the family of straight lines that passes through the origin, uh, say y is equal to kx. This is the second curve. So these set of curves are orthogonal trajectories of each other. They angle of intersection, if you can see, it is obviously 90 degree. So given a set of curves, we are going to find the orthogonal trajectories of other family of curves, and these two family of curves intersect orthogonally. So when I say intersect orthogonally, it means angle is 90. And when I talk about the slope, dy by dx into slope of first one, I can say m1 into m2 should be equal to -1. Correct? Then only we can say they intersect at 90 degree. If you look into the step, first step one is given a set of curve. We have to differentiate with respect to x. If we differentiate with respect to x, what I will get? Dy by dx. And then we are replacing dy by dx by minus dx by dy. Why we are replacing? Just now I said when you multiply two slopes, you are getting -1. That is why dy by dx into minus dx by dy, when you multiply these two, I am getting -1. That's why we are replacing, and I'm talking about Cartesian. Polar, the format is slightly different. And then you got the next set of family of curves, differential equation. From the differential equation, you want the curve means what we will do? We will integrate to get the required orthogonal trajectories. So now let's see this problem. Find the orthogonal trajectories of the family of parabolas. Y square is equal to 4ax. So remember these steps. What is the first step? We have to differentiate with respect to x because the given question is in terms of y, and keep this in mind, it is in Cartesian. Okay. So step 1, we'll write differentiate with respect to x. Now for your easy differentiation, you can keep this 4a as a constant on one side. This side you will be having u by v. Okay. So keep the denominator as it is. Y square differentiation is 2y into dy by dx, because we are differentiating with respect to x here. So this is very important. 2y into y dash also, if you want, we can write. And then minus, write the numerator y square. Differentiation of denominator x is 1 divided by denominator the whole square is equal to 0. So if we do that, because 4a right hand side is just a constant, and if I take this x square to the other side, this will become 0, and we have only the numerator, that is 2x into dy by dx minus y is also there, minus y square is equal to 0. Now if you see one y is extra, if I take this y common, 2x into dy by dx minus y is equal to 0. Obviously we know y is not equal to 0. Then only this value should be equal to 0, or you can take this y to the denominator 0 by y. You will get 2x into dy by dx minus y is equal to 0 by y. So it is 0. Now what is there in our hand is the differential equation of the given family is there in our hand. Now what we have to find the differential equation of the other family, correct? So we have entered step 2, that is replace dy by dx by minus dx by dy. Then only we'll get orthogonal trajectory of the other family of curves. Dy by dx, I'm writing it as minus dx by dy. Other things are same. And this minus, if you can take it and put it on the other side. So 2x into dx by dy plus y is equal to 0. We can write like this. Now you should think about the method to solve this first order differential equation. Now, what is the basic thing you might have studied? Variable separable. What is variable separable? We will segregate 2x into dx by dy is equal to, if you want, you can write minus y to the other side. We can segregate x and dx one side, y and dy other side. 2x into dx is equal to minus y dy, which implies 2x dx plus y dy is equal to 0. Now this is your first order differential equation. Now x and y are on the separate side. If you want, you can write like this and integrate directly, or you can write like this. It's your wish. If I integrate, let me write integrating. This is your step 3. If you integrate, what you will get? 2 into x square by 2 is equal to minus y square by 2. You can write like this or this. It's completely our convenience, plus some constant c. Now if you simplify this, 2 and 2 will get cancelled. X square plus y square by 2 is equal to c. See, this is the orthogonal trajectory, required orthogonal trajectory of the given curve. In case if your question is asked to prove that, then you can take LCM. 2x square plus y square by 2 is equal to c. If this 2 goes to the other side, you will get 2c. You can take let 2c as some k. Then your equation will become 2x square plus y square is equal to k is the required orthogonal trajectory. So for the parabola, this equation, these set of equations and the parabola, they intersect each other orthogonally. So your step 1 is differentiate that dy by dx and then multiply with replace dy by dx by minus dx by dy. That is step 2. And step 3 is integration. Most of the time we'll get variable separable. That is keep x and dx one side, y and dy other side, integrate once. Hence you will get the answer. And sometimes if there are constants, then you have to eliminate the constants. And let us see one more problem in this, which is in polar also. Thank you.